So one piece of announcements, our final review session will be next Thursday, March 15th, 7 to 8:30 p.m. It's being led by Zach and Nolan, who are two awesome section leaders. And yeah, please come show up. It's in 370, and they'll be going over a lot of different types of problems you'll see on the midterm. Come with lots of questions. It will not be video recorded. Okay, so let's talk about inheritance. So inheritance is a way of relating two different classes in a way that minimizes code redundancy between the classes and allows different classes to be treated similarly by the client, which is a topic that we'll come back to on Monday. And as part of this, we'll be implementing a series of classes that build up a system of employees, so different types of employees who are all related to each other. Okay, so inheritance is a way to indicate that two classes are related and a way to share code between two or more classes in a hierarchy. So an important part of inheritance is that you have one class as the parent of another class, that's the child. So generally what that looks like is you have one class extends another, meaning that it absorbs its data and behavior. So the superclass is the parent class and the subclass is the child class. So essentially what you usually see is that a subclass can do everything that a superclass can do, but it might do it a little bit differently, and it might be able to do more. Okay? So an example of this would be the G object family. So you might have seen this in Java, right? But we also have these libraries in C++, and basically there are all these different types of graphics, like a G-oval or G-line or G-label. And then they're all different types of what we call G objects. And the advantage of that is you get to say that there's all this common behavior. So like, various different types of graphics can contain a certain point or have a color or have a location on the screen, right? So it doesn't really matter if what you're displaying is a string text label or a line or a rectangle. They're all going to be somewhere on the screen, right? So get X, get Y kind of means the same thing for all of those, right? But you also have that these different subclasses might have unique behavior or might implement these a little bit differently. So a G label, for example, has a font or has the text that you can set, versus that would be kind of meaningless for a polygon to have. Like, what does it mean for a polygon to be in font Times New Roman, right? So you'd see that by creating this hierarchy, you can take advantage of some of this common behavior and common code, but you also can still implement your own methods that are specific to the class that you're implementing. So what questions do you all have about inheritance, why we might want to do it? Okay, so as part of this example, we're going to implement some classes of employees. So all employees make 40, there are like all of these rules. It doesn't really matter what the rules are. We just wanted to define common behavior for employees. And then in addition to that, we have these types of employees, like subtypes of employees, right? Like lawyers or programmers or secretaries or patent lawyers that can do extra things. So we'll focus mostly on the lawyers and the patent lawyers. So lawyers can do everything an employee can do, but they also know how to sue people, right? Very important skill for a lawyer. Patent lawyers know how to sue people and also know how to file patents, how to make people super wealthy by filing patents. Okay. So I won't code up all of the employee class because it's not that interesting, right? You have these hours, salary, etc. We have this would be our class definition. Okay. So then you can imagine our lawyers can have all the same behavior and they know how to sue. So let's write a lawyer class. Okay? And so our patent lawyers do everything employees can do. They know how to sue and they know how to file patents. So let's write that. Does anybody see any problems with these classes? What'd you say? Yeah, it's a lot of the same code, right? So generally in CS 106A and CS 106B, like at this point in your CS careers, you should know like code redundancy is bad. If we have failed to teach you anything else, like code redundancy is bad. And so you know how to decompose into methods and that sort of thing to try to minimize this redundancy. But in a case like this, we don't have a great way for your patent lawyer to be able to directly call employee. So that's why we have this whole inheritance relationship, is so that you can have, you can take advantage of this shared common behavior. So what that usually looks like in code is you would have class, whatever your name is, like lawyer, and then this colon, which you can kind of read as extends, the Java keyword. They didn't want to make it an actual word for like kind of historical reasons, but they used a colon. It just means extends, public, and then superclass, whatever. So this would look like class lawyer extends public employee. So what this means is now every lawyer just automatically gets an hour's salary, vacation days, and vacation form automatically. You don't need any of that code, right? It just automatically has it. You don't need to write those methods. You don't need to change them in any way. They're just there. So you kind of get all this great functionality. Okay? So, so let me pull up. Okay, so this is our original lawyer code, right? So if we write it to say public employee, now we don't actually need to define any of these methods because they already come in through the employee superclass. And then in here, we can just get rid of all of this code too, because employee already defines those methods. So that code will just be already there for us. So that's really cool. We created like this whole new type of employee. We had to write 4 lines of code. What questions do you all have about that? Okay. So we talked a little bit about these other two. So okay, we have our employee, our employee class, and then we have our lawyer, right? So how do you think the programmer should be factored into this? A programmer does everything the employee can do and then also knows how to write code. So do you think, does anybody have any ideas of what might be a good superclass for a programmer? Yeah. Yep, so we can put this here, so we'll put programmer. Okay. What about the patent lawyer? So patent lawyer does everything an employee can do and also knows how to sue and how to file a patent. Yeah. Yeah, so here we actually can put the patent lawyer to extend lawyer because you have that the patent lawyer does everything that the lawyer does and implicitly everything the employee does and just has this added functionality. So in cases like this, it's actually better to have something that looks like this versus, having patent lawyer as a direct subclass of employee, because you're able to take advantage of the patent lawyer's, you're able to take advantage of the lawyer's sue method in your patent lawyer. Okay. What questions do you have about this? So this then leads to the obvious next question, or maybe an obvious next question of, okay, so this is great because our employees happen to all have the same 4 methods and then we're just extending them. But what would we want to do if we wanted to have these employees have a little bit of a different, to have different behavior, right? So, not all employees make the same amount of money. Not all employees have the same amount of vacation, etc. Right? So this is our same employee example from before, but now we have like some of these extra rules. Okay? So, you might think, okay, well, what if we wanted to just change our lawyer to have a different form, for example? So string lawyer vacation form, which has, this should return pink instead of yellow, right? So just to put this in perspective, let's run the program first. Waiting for it to run. This is our employee main. So yeah, okay. Basically, you end up with, you can see like, okay, here's the employee information for Lisa. We can actually make Lisa an employee, right? Because by being a lawyer, Lisa is an employee. So that's one of the advantages of this inheritance structure. And we can call print employee info for Lisa, right? Here, so okay, so see, they have the same information, which makes sense because they're both employees. So you might say like, okay, if we wanted to change the behavior, a kind of logical thing is let's just write our own vacation form method. So the issue here is it's saying like it doesn't know vacation form exists because it's a method from employee, not a method from lawyer, right? So what's basically happening is that it's trying to use like for lawyer, it doesn't actually explicitly say that, oh, we have this other method called vacation form, so it doesn't know to go look in the employees class for that vacation form, right? So I don't know how you can see it, but the error message says out of line definition of vacation form does not match any declaration in lawyer. Okay. Oops, sorry. Okay. So in order to do this, we have to do something called overriding. So overriding, it involves replacing a superclass's method or member function with a new version in the subclass. So that's what we were kind of trying to do with our vacation form example. But the problem is in C++, you have to use this keyword called virtual, which tells the compiler, like, okay, when you see this method in employee, you might actually have to look more specifically at the subclass to figure out what the actual method implementation is. This might be a method that's overridden. C++ has this is one of those many quirks about C++ that we've grown to know and love over the course of this quarter. And basically just always call virtual. There's not ever really a good reason to not have virtual. So it should always be virtual, both in the superclass and in the subclass. Once you start using virtual, just use virtual everywhere because it will avoid some weird bugs like what we just saw. Right? Yeah. Yes. So virtual only goes in the .h file. And then in the .cpp, it's just like normal. Okay, and then you would also need to make sure you declare that method in the .h file for lawyer, not just an employee. Okay, so so we say like virtual string vacation form. Great. And then here we would want to say, okay, let's make this virtual. Right. And so now when you run it, now it compiles and now it runs. For some reason, it's not saying that it's yellow. Why is that? Sorry, hold on. Yeah. Okay. There you go. I forgot to declare it as a lawyer instead of an employee. So here you see now Lisa is pink instead of yellow, which is good. As an example of why virtual is so important, if we got rid of this virtual here in employee, it doesn't throw any compiler errors, it doesn't let you know anything's wrong, but when we get down here, now it's yellow instead of pink. So always just use virtual. Yeah. Okay, so the question is, do you have to have virtual in your employee and in your lawyer? Technically, you only need it in employee, but it's just like in Java, if you did any inheritance in Java, the methods were automatically declared virtual. Like C++ should have just used virtual, and it should have automatically been the behavior to just use virtual, and they didn't. They messed up. They got it wrong. Other object-oriented programming languages use automatically just have all the overridden methods be virtual. C++ doesn't. So kind of the moral of the story is just use virtual. It's not that much extra code, and it's something that clients using your classes will come to expect. Yeah. Yeah, so you should have virtual on all of these. Even if you don't override them, it's okay to have them be virtual. It just will tell the compiler, like, hey, we might override this in the future. Just keep an eye out and make sure that we're looking for the most specific or the most correct implementation. Yeah. Okay, so the question is, what if you want to override the parameters that are passed in? So in that case, two methods that take in different parameters are actually treated differently. So they would be considered distinct methods. So you can't really override the parameters passed in. Great question, though. You also can't override the return type. Cool. Great. Oh, yeah, way up in the back. Yes. Is that better? Okay. Cool. Okay. So that worked really well with our form. However, we also said that our lawyer gets paid twice as much as our programmer or as our employee does, right? So we could have just put in, we could have written a method like this that just says, okay, int lawyer. We need to put this into our lawyer.h. And then here we would say salary. We could have just said, okay, return 80,000. Right? But the problem with this is, what if we wanted, inflation happens, we want to give all of our employees a 3% raise or something? If we were to do that, then if we change employee, lawyer won't see that change, right? Lawyer will still return 80,000, which means now we need to change code in two different places instead of one, or we are underpaying our lawyers. Neither of which is a great scenario, right? So in order to get around this, we can call and take advantage of the employee's salary method. So what that looks like is you would call salary, and you have to specify that you're calling the employee's salary method, not the lawyer's salary method. Because if you were just to say return salary times 2, that's recursion, right? And as we know, this would be missing a base case. Bad times would happen. You'd be paying them like 2 times, infinite amount of money. Okay, so just anytime you want to call a superclass's member function, make sure you use the class name with the colons. Okay. Yeah. Okay, so the question is, why are we calling this superclass's salary? So in this case, we know that lawyer wants to be paid twice as much as normal employees are, or like non-lawyer employees are. And in order to get the value that so we could just say like, okay, employees are paid 40,000, so we'll be paid 80,000. But the problem with that is if we were to bump up everybody's pay to 50,000, we would want lawyers to then we would want them to be paid $100,000, not $80,000. So if you were just to say, we would then need to like change it in 2 files instead of just in 1, right? So that's why we're calling employee salary. So if we change something in the employee salary method, it will automatically be reflected in the lawyer salary method. Okay. Cool. So we can change that here. So employee salary times 2. Yeah.
So if lawyers never have an employer, would you always just continue copying it into like copying changes in the .h employee into the .h employer?
Sorry, if
If a lawyer didn't have an employer, so it wasn't a super class of employer,
mhm.
then you wouldn't have to copy in the like changes in the employee into the .h.
Okay, so the question is, if we didn't have patent lawyer, would we still need to like copy all these changes from employee into the lawyer.h? And so we would, because like in order for lawyer to have its own salary method, you need to have a salary method defined in the .h file. Yeah. So the question is, did we get a salary method from the last one? So yes, but we didn't get the ability to override from the from employee.h. So we have a salary method from employee.h, but we don't have the ability to override it. We haven't told the computer that lawyer has a more specific implementation of salary. So that's why we need to put like the salary method in the .h file for lawyer. So the question is, you have virtual in both. So okay, virtual technically doesn't need to be in lawyer unless you're going to change the behavior in patent lawyer. But it's good programming practice just to make everything virtual, because you might be writing this lawyer and not think that there's ever going to be a patent lawyer. And somebody down the line is going to want to write a patent lawyer class, or they might want to, and then they're trying to use your class and use inheritance and try to reduce code redundancy, which is great. But they end up trying to implement and override these methods, and it doesn't work. So, did you have a question? Okay, yeah. Can I explain what virtual does? Okay, so virtual does, it like tells the computer, okay, let me pull up employee.me. So here, here we're passing in employee information, like an employee here, and it will print out all this information about that employee, like their salary and vacation days, etc. So what happens is we call employee.salary. If you didn't have virtual, it will just always use this, like this method's employee, right? But if you define it as virtual, then it will know, okay, we need to look for a more specific implementation. We'll talk about this a little bit more on Monday when it comes to polymorphism, which is when you like have a like object declared as its super type, right? Like a lawyer declared as an employee instead of as a lawyer. But yeah, basically it just tells the computer like, hey, there's something more, there might be a more specific, a better implementation. Like go and check to see, is this employee actually a lawyer? And if so, go use lawyer salary instead of employee salary. These are really good questions. So. Okay. So, okay, that kind of covered, we wanted to have different behavior, so we wanted to have, extra behavior for the subclass, right, like being able to sue. It also covered that we wanted to have different types of employees have different implementations, right, so you wanted a lawyer to be paid more. Now the question is, what if we want to change the behavior of individual instances of these classes, right, like not all lawyers are the same. Not all employees are the same, that sort of thing. So in general, what would we have to use in order to have each instance of a class have different behavior? Yeah. Yeah, so basically in general you would have to have a constructor that takes in these different parameters. So okay, let's just say we have years, Employees make $40,000 per year plus $5,000 per year worked, which is a great raise. Okay. Here we can write our constructor. So let's say we have employee, it takes in years, right? We'll make our private fields, private in years. We'll call this my years. We'll declare it down here. Employee years equals my years. Okay, and we'll do the same thing for lawyer. We'll give them a law school. And they also get a constructor. Okay. We also need to change our employee dot. So we need to change this to be plus 5,000 times my years, times years, right? And then we need to change employee main, which, okay, let's say this person's worked for 2 years. Let's say she went to Stanford Law School. Okay? Any questions about the changes that I just made? I just like implemented constructors. Yeah. The question is, where do I put my years? Okay, so where do I put my years equal to years? So that's in the implementation of the constructor, which is in the .cpp. Yeah, so basically the .h has the constructor declared, and then the .cpp implements it, and the main actually uses the constructor. So those were the big changes I made. Yeah, do you have a question?
Yeah, so you never passed in like a constructor for employee, and the lawyer's extending employee. So what is the implicit constructor that it's going to give?
Okay, stick with me for like 2 minutes, and we'll see. Great job. Yeah.
Should that be a multiplication instead of an emphasis?
Yes. Yes, it should. Okay. So, okay, let's try running it. See what happens. Today I'm just showing you a lot of weird Qt Creator bugs. Oops. Hold on. Okay, so it's saying, how many of you have ever seen symbols not found for architecture x8664? Yeah, for those of you watching at home, you're probably also raising your hand, because everyone here just raised their hand. So I don't know if you've seen, you can go to compile output. Okay, so it's saying I didn't implement my lawyer constructor. Lawyer, string my law school. Law school equals my law school. Okay, let's try this again. Okay, so now it's saying constructor for lawyer must explicitly initialize the base class employee, which does not have a default constructor. So this is going back to your question. So what's happening here is whenever you create a lawyer, you're also creating an employee, right? Because lawyers are subclasses of employees. In order to create an employee, you have to call this employee constructor here that takes in a number of years. Okay? And so what's happening here is it doesn't know how to call the employee constructor because you would have to call it with a number of years. This is kind of a subtle point. What questions are there about that? Yeah.
So in order to fix that, would we have to like include parameters for employee within the parameters for lawyer?
Yeah, so the question is, in order to fix that, do we need to change our constructor so it can take in the parameters for employee? So yes, that is totally right. So here we can take in like an int my years. Have to change this here, my years. And then our employee main would have to change this. So maybe this person has worked for 4 years. Okay, so let's try running it again. And it's going to still have that same issue because even though we gave it the number of years, we have not actually told it what to do with that number of years, right? So the syntax for that looks like this, where, again with the colons in C++, but basically you have the constructor, and then you put a colon and you put the superclass name with the parameter. So that's calling the superclass's constructor. So in this case, it would look like this, where you can say like employee of my years. What questions are there about that, like this syntax? See, and now we can run it, it compiles, and indeed now you do have some variability based on the number of years that that person has worked. Yeah. So the question is, sometimes you can have default parameters where it will default assign a value if nothing is passed in. So you could do something like, okay, let's not have this. Have our employee may not have passed this in. Lawyer.age not taken a number of years. And instead of having this number of years, we will say that, okay, int my years, and we'll default initialize it to 0, because we figure when you hire, you don't have any work experience. So it should work, yes. So it does in fact work. The downside of this is really every time you make a lawyer, you do want to be making an employee. And if it makes sense that employees can be hired with non-zero number of years, then it would also make sense that like a lawyer would be able to be hired with a non-zero number of years. So although default parameters would get around this issue that I was talking about, they still are not the best solution. Great question, though. Okay. Okay. This is kind of our final lawyer where they can take in a different salary, they can sue people, that sort of thing. And then here's all of the different methods that we implemented. Just to reiterate, you have this constructor that calls the superclasses constructor. And then we're making sure that when we are overriding methods, if we need to call the superclasses methods, we use like the superclasses name here. And then also making sure in our .h file that we use virtual for our methods. Okay. Any questions about kind of the mechanics of inheritance? I know C++ has kind of some really bad syntax here. C++ messed up, but the principles of inheritance are still the same. Okay, so let's talk about some of the perils of inheritance. So I've told you all this great way to like minimize code redundancy and show these relationships between classes, and you might think like, oh, now I want to use this on everything. Or maybe not, because you're like, wow, that was a lot of just garbage syntax. I never want to have to deal with that. But there are some cases where you don't want to use inheritance. So why don't you talk with a neighbor and try to see like if you would want to use inheritance in any of these 3 circumstances, or if you wouldn't, why wouldn't you want to use inheritance? Wow, it's like the least quiet conversations I've ever heard, or most quiet conversations I've ever heard. Okay, so what do you all think? How many people think that you should use inheritance for the 3D point versus the 2D point? How many people think you shouldn't? Okay. Yeah, the slide is called Perils of Inheritance if you're just using that. What about square and rectangle? How many people think you should? How many people think you shouldn't? Okay, and how about sorted vector and vector? Should and shouldn't. Okay, so actually in all three of these cases, inheritance isn't quite the right approach because of basically it changes the expected behavior. So if you call points 2D distance on a 3D point, that's going to have like the wrong behavior, right? Because you want to incorporate the z coordinates as a distance away, right? So, you could be at x, y, or 0, 0, but you could be like 50 feet in the sky, right? Or something like you're on a skyscraper. So you might be at the same, x, y location, but different z location. And so that distance shouldn't be 0. Yeah. So the question is, what if you do point 2D extends point 3D and initialize the z coordinate to 0? That would be a better choice because then you kind of have less of this unexpected behavior. Though you get into, should a 2D point be able to set, like maybe there's a set z coordinate or something for the 3D point, and so should a 2D point be allowed to have that functionality? And in that case, like that still might not be the right approach. We will get to that. Good question. Yeah, and then a rectangle doesn't have, or a square shouldn't have a set width versus set height method, right? That doesn't really make sense for a square. And then a sorted vector could confuse a client because what if you say, okay, vectors you can insert elements at index 0, and then if we go back and the next line of code that we get is we print out this vector and the indices are all in the wrong order, or with recursive backtracking, there was a lot of like insert things at the beginning of our vector, recurse, delete things from the beginning of our vector, and if that thing that we're deleting is not the thing that we added, that could cause a lot of bugs. Okay? So this gets to something called Liskov's substitution principle, which essentially is that you should be able to replace a class with an instance of its subclass and have the same expected behavior. So part of why I wanted to bring this up is this is named for Barbara Liskov, who is like phenomenal with object-oriented programming. She kind of redefined how people think about object-oriented programming and created a lot of these principles that really guide how people program with classes and inheritance and things like that today. She's also, do you remember when I talked about the Turing Award with Dijkstra? Yeah, so she won the Turing Award too, and she's phenomenal. She's like one of the first women in the U.S. to ever get a PhD in computer science. She's one of the first women to ever win the Turing Award. Like, really top-notch computer scientist. Cool. And if you can't see I don't know how you can see this in the back, but it says, if it looks like a duck, quacks like a duck, but needs batteries, you probably have the wrong abstraction. Because you can't replace a duck with a mechanical duck and expect it to have the same behavior, right? Okay. So now you're all thinking like, okay, we learned about inheritance, then we learned about these perils, and there doesn't seem to be a great way to get around it. What if I legitimately do have all of this redundant code that I want to take advantage of? Like what you were saying about the 2D point and the 3D point, and kind of ways to hide that behavior. So there is something called private inheritance. Remember when I said that you had to have class lawyer, public employee? So you can also have a private, so that's public inheritance, which means that the client can call any of the employee methods on a lawyer object. Private inheritance means you get all of the code, but you don't get the methods, if that makes sense. So clients would not be able to, if we were to have like class lawyer privately extends employee, you wouldn't be able to call all the employee methods on the lawyer object unless the lawyer object explicitly defined those methods. Okay, so generally we would do this for something like a sorted vector where we might want to hide the insert at index or something like that. Or in the 2D point example, if we had the 2D point extends the 3D point, then you might want to hide the change z coordinate method of the 3D point, so you wouldn't choose to make that method public. What questions do you have about that? Yeah.
So I guess it's just like, what would be a real example when you want to do this? Because it seems like the point of hierarchies are you build out more and more methods with the same, but now it's kind of like doing the opposite where you have a lot of good methods to use and you can like restrict that back down. So it just doesn't seem very like intuitive.
Yeah, so the question is like, this doesn't seem all that intuitive. Why would you ever want to do this in the real world? Basically, you would want to do this like a square and rectangle, like this G square and G rectangle would be a great example because you want to hide the get width and get height methods. And you also wouldn't want like a rectangle to have like a set side length method or something because that doesn't really make sense for a rectangle. So you like, but you do want to have, like drawing a square is basically exactly the same as drawing a rectangle, right? And checking for an XY inside a square is the same as checking for an XY inside of a rectangle and that sort of thing. So that would be a real example where you would want to maybe privately inherit from grect if you're making your own G square. Cool. Yeah.
What does the code look like? So like if we copy the code but not the functions, how does that?
Okay, yeah. So the question is, what does this code actually look like? So let's go in here. So let's say we privately extend employee. So what that kind of means is, first off, you can't ever say that, okay, we no longer acknowledge that Lisa is an employee. Lisa is just secretly an employee, so we as the programmers know that Lisa is an employee, but the client doesn't. So we can't call this print employee info anymore. So, okay. Here. So let's just call her employee and comment this out. Right. So then now what it says is vacation days is a private member of employee. So now it's like vacation because if we go back to our lawyer.h, we don't ever declare vacation days. So instead of all of those methods from employee going into the public portion of lawyer, it's kind of in the private portion of lawyer. So it's like a private helper function. So when we go here, you get this, like vacation days is a private member of employee. So you can't actually call vacation days on a lawyer object.
So it makes it so that we'll make it so the client can only call what we want as well.
Yes, exactly. So just to reiterate, it makes it so that the client can only call the methods that you want it to call. So if there are like harmful methods in employee, you can kind of get rid of that. Yeah. So let's say you want to have our salary is based on the actual salary times 2 minus like vacation days times 3 or something. So you can say vacation days times 3. So let me get rid of this line so we can compile it. So here you see that we've actually subtracted 30 because there are 10 vacation days. So it's used exactly the same way internally. It's just not used externally. It's kind of like you probably wrote a bubble up or bubble down method for your heap. Hopefully you've decomposed it in some way. So it's kind of like that where you could call bubble up, but the client could not call bubble up. Yeah. So the question is, do you still have to use virtual? I know virtual is like a real drag, but like you technically don't because, okay, so virtual, this will make more sense on Monday when I talk about like calling, like you're saying that a lawyer is an employee. But because you kind of get rid of that functionality, you don't need to have virtual as much. So.
Don't you use employee and then like with the salary justification days?
Yeah, so the question is, why don't we need to say something like this? So it's not wrong to say this, but essentially we're calling lawyers vacation days, and lawyers vacation days just happens to be employees vacation days. So we don't need to explicitly say go to employees vacation days because there's nothing in the lawyer class that would like conflict with the employees vacation days. What did you say?
Did you specify that in the
Specify what exactly? So we did that in the .h file by saying that we're extending employee. And because we don't have our own vacation days method for the lawyer, then it'll automatically use the employee's vacation days. Great questions. Yeah, if you're interested, another way to kind of get around this that's a little bit more intuitive is something called composition, which instead of saying like, okay, I'm a I'm a square and I'm going to say that I'm also a rectangle, or like I'm a sorted vector and I'm going to say I'm also a vector, you instead just keep like a vector as a private instance variable. So then whenever you need to call, get at index whatever, you just return, your method would look something like vector.get whatever on your instance variable. So if you're interested in that, that's called composition. Yeah. Mm-hmm. Yes, the question is, if you privately inherit, what does that actually, like, is that equivalent to saying, okay, so we privately inherited from employees, so we take all of employees' public stuff, and we basically are putting it privately down here. Not the constructor, but the rest of it. Yeah, so those are equivalent. Or not, those are logically equivalent or conceptually equivalent. Yeah. Yeah, so, okay, so that's what's happening with the employee, basically calling this private, like saying that we privately extend. This is not actually written like that, and so what then happens is, since we publicly have vacation form here, that takes precedence, so we do have a public vacation form. Great question. Yeah.
If we wanted to have the vacation days public,
Mm-hmm.
but like functionally the same as employee,
So the question is, if we did want to have vacation days be public, virtual, I think it's an int, vacation days. So the way that we would do that is in our lawyer, we would have int lawyer vacation days, and then we can just return employee vacation days. And that's a really common model that you'll see, where you're just calling this superclasses method. Okay. Great questions. I just wanted to very briefly touch upon C++, unlike basically every other object-oriented programming language like Java or Python, allows you to do multiple inheritance, which allows you to say that something is two things. So, for example, there are input streams and output streams, right, in C++. And so you can write that as an I/O stream, which are both an input stream and an output stream. It's a stream you can read and write to. One of the reasons why most other programming languages don't have this is because a lot of times people will be like, okay, I have like a baby class and I have a dog class, so I want to make a puppy class. So a puppy both is a baby and is a dog. So I'll just extend both. And then like all of a sudden your code just breaks because babies eat very differently from how dogs eat. And babies make different sounds from what dogs make. And so which one should puppy have? Right? So, yeah, that's basically multiple inheritance. You don't really need to ever do this. Great. Thank you so much, and see you on Monday.